All right, so for this final video, it's just the miscellaneous math problems that I have laid out. Um, these are the ones that I think are most true to how I remember the exam. So especially the second one not so much, but the other three are definitely ones that I think are pretty loyal. Um, so getting straight into it, patient weighs 128 pounds, is 5'11". Drugs amophilin requires dosing of 120 milligrams per meter squared. Dosed orally every 12 hours. If the patient requires a 2-week course, how many milligrams will they be given over the full course of therapy? So our we have our initial values and we just went through the direction. And so we're trying to find the final uh, full milligrams. To get that, we need the dose, so how many milligrams per dose, and that's the big key. And to get the dose, we need the BSA. And the BSA, we have all the initial values for. So our BSA, make sure that's coming through, BSA is equal to the square root of 71, because 5 feet is 60 inches plus 11 makes 71, plus 128 plus multiplied by 128 pounds divided by 3131. That is our conversion value for the imperial measurements. That's 71 times 128. That's 9,088 divided by 3131 makes 2.9. And then the square root equals 1.7 meters squared. And we multiply that by our dose, 120 milligrams times 120 milligrams. So we have, so that is 204.44 on the dose, per dose. And then each dose is given every 12 hours. So that's 2 per day. So multiply that by 2 times 14 days of therapy makes it 5,724.43 milligrams. Moving on, excuse me. Moving on to the next problem. How many milligrams is needed to make 30 milliliters? 30 milliliters of 1% morphine sulfate isotonic. So that's 30 times 0.1 gives 0.01 gives us 0.3 grams morphine sulfate. Morphine sulfate. And then our equivalency, our E value is 0.14. So 0.3, 0.14 is 0.042 grams NaCl. So 0.3 grams of morphine sulfate is equal to 0.042 grams of sodium chloride in terms of isotonicity. Then we subtract that from the total amount of sodium chloride. So that times 0.009 is equal to 0.27 grams minus our 0.042. Where did that eraser go? There we go. Minus 0.042 equals 0.228 additional grams. It's been grams. Of sodium chloride. And for the final conversion, we multiply that by 1,000 to get to our milligrams, because our last value is milligrams of sodium chloride. And again, we have no decibels for this one, but just going through, we just want to watch our decimals each time we finish one of these problems. And then again, at the end, we loop back, check all of our decimals again, because that's like you make it to the finish, but then you fall right at the decimal line. That's it's an easy way to lose points, but it's also an easy way to get your points back. Not back, but make sure that you do get them on the first try. Okay. This is another isotonicity problem. I have a lot of them because they're confusing and new, and I feel like that's worth exploring a lot. So how many milligrams of boric acid will it take to make the following isotonic? We have bromonidine tartrate. We have 0.15 grams times E value of 0.18. I'm getting ahead of myself. Boric acid, that'll come in at the end when we do our sodium conversion, and a total volume of 60 mils. And since we have no other volumes that are already isotonic, we can just take our 60 times 0.009. This is the 0.009 throughout this entire thing has just been calculating the normal saline. So 0.009 gets us 60 times 0.009, 0.54 grams of sodium chloride minus parentheses are 0.15 times 0.18 for this. That's that equation there. Minus parentheses 0.15 times 0.18 gets us to be 513. Looking good. So this is grams of sodium chloride that we need to add to reach isotonicity. But since it's asking for boric acid, we just divide by 0.52 and divided by 0.52 gets us 0.986. And for decimals, we'll just go 0.99 for simplicity. That is that one. And then our final one so far, and this is a document that I plan on continuing adding to if I come up with anything else. Our final one so far is a wizard shows up to your pharmacy looking for a salve for demonic curse. Since none of that is real, you give him 5 fluid ounces of ABH-PLO gel with the following ingredients. ABH gel is something that they give to people with dementia to keep them sedated. Whatever. How much of each ingredient will you need? So for Ativan, we need 5 mg per mil, 12.5 mg per mil of the Benadryl, and the haloperidol is 2 mg per mil. And so it's asking for all 3. Normally in a question, you just ask for one aspect of it. But I'm just going to do all 3 because it's good practice, and going through those practice worksheets, it's also helpful to just do as much of it as you can, like Dean Sanoski's practice worksheets. Doing a bit more can really help you in securing that information in your head. It's just extra practice for the same amount of worksheets, Okay, so we first have to convert. So initial values, we have our concentrations, and we have 5 fluid ounces. So we need to get 5 fluid ounces into mLs, just so we have units that can talk to each other. So 5 flaws times 30 mil per flaws is 150 milliliters. 150 milliliters times each of our items. So we have 1 mg per mil. So that's 150 Ativan. 12.5 I can't do in my head, so multiply 12. Oh, Jesus. Rough. 12.5 per ml gets us milligrams. All of this I'm doing in milligrams because the RX is calling for milligrams per ml. Anyway, 1,875 milligrams diaphen, and then it's 2 mg per mil for the haldol, which gives us 300 for haldol milligrams. Haloperidol. So these questions are the most like the exam, and in her questions there are usually a lot more conversions. And like I said in the first video, you're going to have conversions where you go from imperial to metric back to imperial. You're going to have questions where you'll need to convert MEQs back to milligrams just to be able to do another conversion equation, just to make things make sense. It's a lot of that, and it can be really frustrating. And it's one of those things where you really just need to, it's a balance between taking your time on problems and being able to kind of automatically look at a problem and go, I know from what I just read in the directions. And that's a part of the important directions part, is as you're reading through it, like you go through it once, and then immediately after, before I go back into the directions, I think, what kind of last value can I expect? And what kind of formulas can I expect to use to get from initial value to last value? And that is something that's kind of difficult unless you do problem after problem after problem. So keeping on those practice problems, and honestly making these practice problems has been really helpful for solidifying knowledge, because it identifies gaps. And if you want to go into the our Google Drive for PDC and alter things, or add questions on that you think, hey, I think this might be pertinent, then I highly recommend it, just because it really helps you. It shows you where your gaps are, and it shows you where your strengths are. But yeah, that's just kind of my view of things. So this is the last video. For now, I might be coming out with more problems. These will be uploaded somewhere. And then the link will be shared with you guys. All right. That's all I got. If you have any questions, please just email me. Email or call. I think my number is in the group me. So yeah. Have a good day, guys.